Hey, bonus lab time here, my friends. We're going to do another variance lab here. And I know in the last section I talked to you about why you don't just say variance 128 every single time. But you know me, I don't want to just tell you how to cook. I like to show you how to cook. And that's exactly what we're going to do with the variance command here and discuss and then see why you don't just set the variance to 128 every time. It's something you should be aware of, because there are two really good reasons not to just set it to 128 or in the future whatever its max is. The CCNA exam is likely going to want you to use the lowest variance command possible, or the lowest variance value. Then I would anticipate that any future Cisco exams you take, and perhaps non-Cisco exams, will want you to do the same thing. So, because they want you to demonstrate that you know what's going on with the variance command. That's fair enough. Also, in lab and production environments, if you just do a ridiculously high variance, then you're likely to bring in routes that maybe you don't want to use for load balancing. There is no cut and fast or hard and fast rule for that, but I want you to see the impact, and it's something that in a production and a lab environment I would keep an eye on. To illustrate this, I have added another link to our network. I've added a 64K link between routers 1 and 3. That's over the network 172.12.13.0/24, and I've already got it configured up and running and added to the EIGRP network. Now at this point, router 1 has 3 paths to get to router 2's loopback. It could go over the frame network 172.12.123.0. It could go over the frame directly to router 2, and then you're at the loopback. It could go through the frame 172.12.123.0. It could go through there and go to router 3 and then go over the Ethernet and go to router 2, and then you're at the loopback. And now it can go over the 64K line to router 3 and then through the Ethernet and then to router 2. Now, the assumption of a Cisco serial interface is that it's running at T1 speed. The bandwidth is going to be set at 1544. So let's see what that does with our metrics when we bring in a 64K link. First off, let's look at the topology table. We see that we've got 3 entries now for router 3's loopback and 3 entries for router 2's loopback. So here's the new route, and the new route would be through 1313.3, and it does pass the feasibility condition because its reported distance of 409.600 is less than the feasible distance of the successor, which is 229.78.56. But look at this huge whopping metric. That's a big metric, and it's a lot bigger than 229.78.56 or even 232.34.56. Pretty darn big. So if we were going to bring that third path in for unequal cost load balancing, we would have to raise the variance to 18. And we're going to do that. And also I wanted to show you in the routing table, by the way, that route doesn't appear. The 1 through 13.3 does not appear in the routes for the network for the router 2 loopback. We're seeing the 2 that we saw at the end of the last lab. So let's go ahead and change that variance to 18. Feels funny even typing that. And, let's put in clear IP route. Asterisk, that gets rid of all of our dynamically learned routes. And look at that. There's the third entry now, of course, both for router 2's and router 3's loopback, because the variance command is all or nothing. So now we are using that third link, and you could see there's a big speed difference here. So we have successfully brought that link in via unequal cost load balancing and using the variance command. And to get that 18, all I did was divide that 40665,600 by 229.78.56, and it came out to something like 17.4. So I just raised it up to 18 because 17 wouldn't have done it. Now here's the deal. EIGRP unequal cost load balancing, it is proportional to the metrics by default. So EIGRP in this case would not try to shove 1/3 of the load on each 3 of these links, because EIGRP is very smart and it's going to look at this and say, okay, you know, I got two links that are pretty close to each other, and I got one link that's much slower, 18 times slower, so it would proportionally divide the load up. Now, there are formulas on how to arrive at that you can get on Cisco's website. If you do a quick Google search on EIGRP unequal cost load balancing, you would find it very quickly. It's way beyond the scope of the CCNA, so we're not going to go over it here, but you could figure out exactly what those proportions would be. The key here is that even though EIGRP, even though it's going to be proportional, when you've got paths involved in load balancing that are that much slower than the other paths, I would just keep an eye on it after configuring it, production or lab-wise. I would test in a lab before I did production if at all possible. Because as I like to say, just because you can do something, it doesn't mean you should. But this is another great example of how we arrive at the variance command, which one we want to use, and not just slap 128 on there, because not only is that not going to do our production networks a world of good, it's not going to do our exam score much good either. So we have really hammered the variance command here. I know you've got it down. You know exactly how to use it. You know how to get the variance that you need. And now that we've done all that, now we're going to head to auto summarization. I'll see you there on the next video.